Good morning once again to all of you. Next topic which we are going to study is impurity defects found in covalent solids. In my earlier video, I had told you about doping. What is doping? Doping is the process of addition of impurities which helps us to increase the electrical conductivity of a crystal structure. Here, doping, when I say about covalent solid, addition of any covalent. Based on this, there are two types of solids which we are here calling them semiconductors. Number one, they are, and I'll be speaking solely so that when you see your video, simultaneously you can write down these notes also. There are two types of impurities which are found in the covalent solids, and because of that there are two types of semiconductors. Number one I'm going to discuss is N-type semiconductor. Suppose we have an element of group 13, say boron chloride, and to this element of group 13, okay, let's do something else. I'm giving you a different example. We have an element of group 14, say silicon tetrachloride, SiCl4, which you know is a covalent solid. To this covalent solid, I add phosphorus pentachloride. Silicon belongs to group 14 of the periodic table and phosphorus belongs to group 15 of the periodic table. Okay, what will happen? At few places, silicon atoms will be replaced by phosphorus atoms. ध्यान से सुनना, you'll be able to understand. I have silicon chloride crystal. In this silicon chloride crystal, I add phosphorus pentachloride. At few places in the crystal, silicon atoms will be replaced by phosphorus atoms. Silicon valency is 4, but phosphorus the valency is 5. There will be one extra electron. That extra electron, since an electron is negative, that extra electron is responsible for enhanced electrical conductivity, and since that electron is negatively charged, such type of a semiconductor is called N-type semiconductor. Small n, not a capital N. Small n-type semiconductor. So whenever you dope an element, a compound of lower group with a compound of higher group, since extra electrons are produced, this type of semiconductors are known as N-type semiconductor. Another type of semiconductor are P-type semiconductors. Okay? Suppose you have silicon tetrachloride. Again, I am taking the same example. And I add a little amount of boron trichloride to it. मतलब हमने सिलिकॉन टेट्राक्लोराइड जो ग्रुप 14 का एलिमेंट है सिलिकॉन, उसमें हमने बोरॉन ट्राइक्लोराइड डाल दिया जो कि एक ग्रुप 13 का एलिमेंट है, उससे लोअर ग्रुप का एलिमेंट है. What will happen? Some of the silicon atoms will be now replaced by boron atoms. Earlier, some of the silicon atoms were replaced with phosphorus atoms. Here what will happen? Some of the silicon atoms will be replaced by boron atoms, and since valency of silicon is 4 but valency of boron is only 3, कम हो गई, positive holes will be created or vacancies will be created, and since it is positively charged, it will be called, such type of a semiconductor will be called P-type semiconductor. So agar a compound is doped with an element of higher group, it gives you N-type semiconductor. But if a compound is doped with lower group, it is called P-type semiconductor. Both are responsible for increased electrical conductivity. In N-type semiconductor, since there are excess electrons, they are responsible for increased electrical conductivity. But in the P-type semiconductors, suppose we have a P-type semiconductor in which there are positive holes. If electric current is applied, this positive holes start moving. If electric current is applied, electrons move from left to right and positive holes will start moving. For example, we have a positive hole और उसके बगल में electron है. So what will happen? This electron will occupy this position. This is an electron and this is the positive hole. Okay? What will happen? If you electrical conductivity, how will it be maintained? This electron will occupy this position so that a positive hole will be created here and electron will be produced here. So as you pass electricity, electrons keep on moving this side, and the positive holes keep on moving to the other side, increasing its electrical conductivity. This finishes your defects in the crystals, purity defects, all type of defects I have discussed. Now a few questions which I will give in the WhatsApp group only. Few questions which I will give again from this related part in the WhatsApp group only. One important question, name a crystal जो अक्सर पूछा जाता है एग्जाम्स में, which shows both Frenkel's and Schottky's defect. Your answer is silver bromide. Which crystal structure shows both type of defects, Frenkel's as well as Schottky's defect? Your answer is silver bromide. Okay, chalo. Now in my next topic which I am going to discuss is the electrical properties of the crystals, and next property will be the magnetic properties of the crystals. Now in the electrical properties, we know they are divided into three types. Number one, paramagnetic substances. Sorry, we talk about let me talk about, okay, I'll talk in my next video now. Okay.